Hey everyone, welcome to ledbylearners. And today we are going to explore one of the exciting chapters in class 9 science, which is motion of physics. So don't worry, we won't make it boring. We will make it fun, interactive, and super easy to understand. Okay, so let's get moving into the chapter. So first of all, what is motion? Okay, before going to in deep, what is about motion? You guys must have learned about what is motion, the basic definition of it. So we'll just recap it. So let's kick things off the basics, which is motion. Simply, it means that when an object changes its position over time, it is known as motion. For example, you can see on my screen there are a bunch of kids playing a game of tag, which is also a motion in this case. Okay, okay, and we all must have played that game of tag. All right, and when someone says, what is stationary? Like, example, the car is stationary, the ball is stationary, etc., etc. So it means that a object is not in motion, okay, which is called stationary. But there is another twist as well. For example, imagine you're in non-motion, but you're still in motion. You know why? Because the earth is revolving. That's why you are in motion. Because of the earth revolving, if you even if you are not in motion, you are still in motion. Okay? So now we must have now who which those people who don't know what is motion, they must have understood it with this video. Now we'll be studying types of motion, okay? So let's get going into the. So there are two types of motion which we'll be studying according to CBSE, which is uniform motion and non-uniform motion. Okay, so let's get going into the topic. Firstly, we have uniform motion. So what is uniform motion? What do you mean by uniform motion? This is when an object, covers equal distances in equal interval of time. Think of a robot vacuum cleaner moving at a constant speed. It's like on a mission to clear your room with a military precision. Precision. Okay. So now next we have is non-uniform motion. So non-uniform motion is nothing but when an this is when an object covers unequal distances in equal interval of time. Imagine a cat chasing a laser point, which is as you can see in my screen, and which if you guys have seen it, first it speeds up, okay, then it slows down, and then it changes its direction, which is classic non-uniform motion. And you can understand with this example. If you have understood it, then good for you. Okay, next we have about speed and velocity. Most of you may be familiar with speed but not with velocity. Don't worry, we'll also cover that in this video. So don't worry, just sit back and understand and see the video. So speed tells you how fast an object is moving, okay, while velocity also tells you the speed but as well as a direction, okay. And you can say that speed is a scalar quantity and velocity is a vector quantity. So what is scalar and vector quantity? Scalar quantity is nothing but when it describes the speed of an object but not the direction, whereas vector quantity tells the speed and the direction of the object. So you must have now understood what is scalar quantity and vector quantity as well. So example, you can see you are running fast to your teacher at the speed of 10 kilometers per hour, which every one of us do to submit our homework. Okay, you are running fast. You don't understand that I should just give the homework, otherwise I'll be put into the detention. over principal's office, or many worse things could happen. So you run fast as as much as possible. In the other case, we can see that you are running, okay. For example, you have to just submit your project, you have time for that, so you don't hurry up. But then when you do that, you have to submit it, you won't run fast, because that's the day to submit the particular project of your particular subject. So you would you know uh, head towards a particular direction. For example, in the example I've given, you are running. Second case I've given, you are running, but at the at the direction of north. So now next thing we are going to learn is about acceleration. So this concept also must be familiar with you guys, so we'll also cover that in this video, and it is a new concept as well. So let's get going into the concept of acceleration. So acceleration is nothing but the rate of change of velocity. Now I have mentioned you what is velocity. Okay, so you must be familiar with that, and that is the rate of change of velocity is known as acceleration. And the formula for acceleration is initial velocity minus final velocity by time is known as acceleration, which is also denoted by u minus v divided by t. For example, I've given you two examples, walking to running, or else if you don't understand like that, just think of your mom instance. She's sprinting towards your report card. Okay, she's changing her velocity because you got your report card, and she must be curious. How much did my child get on his or her report card? So that's the case of acceleration. If you must have understood it, good for you. It's a you know I thank you so much for understanding it. It's a very important chapter. I mean concept. Sorry, my bad. So next thing we'll be learning is the real life applications. Okay, some real life applications as well to make your understanding more broad. Okay, about this chapter. Okay, because it's the first chapter of physics, and you'll have some numericals also, which we'll also solve. Not in next video. In next video, I'll bring some other subjects. You know, some other subjects chapter introducing in the next content of my YouTube channel. Okay, so not in this video. So anyways, before going to that, real life applications, we have three equations of motion. You should be memorized with these three equations of motion, which is v equals to u plus at, and then s stands for uh, distance, equals to ut plus 1 divided by 2 at square, and the third equation, which is v square equals to u square plus 2as. These three equations are the most important equation, which you should memorize it. This will help you a lot in the numericals, which we are going to solve also in the upcoming videos, as I said. Okay, now we'll study the real life applications. Okay, so roller coaster, it speeds up. In the case of roller coaster, it speeds up, it slows down, and it changes its direction. If you have rode on a roller coaster, but in driving a car, you use gas and brakes. There is a lot of excessive use of gas as well as brakes. Okay. Next, we'll be representing motion on the graph. So as you can see, uniform motion on time graph. So it has started. Always when an object starts, whether it is uniform or non-uniform motion, it always starts from the quantity zero, and then I have shown you it has gone up to it has gone up to straight line. So uniform motion literally means that an object which has covered in a straight line over equal interval of time with respective to the equal distance, okay, of the y axis to the x axis. Okay, this is the y axis. If you see my arrow, this is the y axis about 3.5, numerical value, and this is the x-axis. So I have just given these graphs for representing these numbers. So don't get panicked with seeing these numbers. All right, but you can see that it has covered equal speed and uh, equal interval of time, which is meter per second. This is the y axis. Towards the y axis to the 0, which is 3.5 to 0, is actually the speed. Okay, and to 0 to 3, it is actually the time taken by an object. So that's what it means, uniform motion on a time graph. All right, now we'll be seeing the representation of non-uniform motion on the time graph. Okay, so non-uniform motion on a time graph is where it covers unequal distances in equal interval of time. There is an equal interval of time, but in not in equal distances. For example, you can see it has not covered it. The object was going to 0 till it has gone up to 3, but then it has suddenly it has a retardation. Now what is retardation is nothing but a negative value of acceleration. Okay, it is opposite to acceleration. Now we have constant velocity on time graph. Now what is constant velocity? It is nothing but when an object covers. For example, you can see it has not gone to 0 because it was not drawn. Sorry, my bad. It was not drawn very accurately. But then the object, if you see my arrow, it goes up to 0 till a particular value. Then it remains the same on that value. For example, as you can see my arrow, my arrow is on 0. Now it is going up. It is going. Then when it reaches to 2.5, it will remain 2.5 only at the mark of his journey of an particular object. It will remain 2.5 no matter what. Okay, now we have velocity time graph. It represents the slope of a time graph. Okay, for example, you can see the 0 to 3.5 is a slope. It is a slope. It's not even constant velocity or non-uniform motion or uniform motion. So it is a velocity time graph. As you can see, the slope itself indicates that. All right, so hope you might have cleared the concepts of it. Now I have a quiz for you guys. I'm leaving this in comments. I'll also comment to this. Okay, there is a car which starts from rest and accelerates uniformly over a period of 5 seconds to cover a distance of 50 meters. Find the acceleration of the car. So I leave this to you guys. I'm just giving you this question so that you will I'll get an idea that what type of is your mind when you have seen this video, and that will help me um, record my videos and present it to you guys. So just give it a try. If you can't do it, I'm available here. I'll solve it in not in next video, whenever I'm uploading a video of the physics of chapter motion numericals part. So we will cover that. All right, so no need to worry about that. If you can do it, do it. If you can't, I am here. Just comment that you didn't you're finding difficulty, and what part you are finding difficulty. I just want to know that. Okay, so yeah, now to the conclusion we come to that motion helps us understand in our everyday life. Okay, and it helps us in our exam as well. This chapter motion has a very big concept